All right, let's dive into the world of habanero peppers today. We're going way beyond just the heat, though.
Yeah.
We're going to explore how scientists are capturing some of the other good stuff inside these peppers and figuring out how to make it last.
Yeah, we're going to be looking at a research article from 2023 from the scientific journal Processes. It dives into optimizing the spray drying process for habanero pepper extract.
Now, I know the title of this paper might sound a little intimidating with all the technical terms, but believe me, the findings are really interesting. Think about it this way. We all know habaneros are hot, but they also have a lot of beneficial compounds, like antioxidants. This research is all about how to best preserve those compounds so we can benefit from them.
What's cool is that this paper goes beyond just like describing the process. It actually analyzes like the characteristics of what you get in the end, the final product, and that's where it gets really exciting in terms of potential uses.
Okay, so let's start with the habanero peppers themselves. The researchers use peppers specifically grown in the Yucatan Peninsula in Mexico, in a region known for a specific type of soil called tequilum. What is so special about this soil, and how did it affect the peppers?
Well, teculum is a type of soil called lithic leptosol, meaning it's very rocky and has a high percolation rate. This actually makes it challenging for plant roots to develop and to access water, which impacts the peppers themselves. The researchers found that the habaneros that were grown in this soil had a lower moisture content than what's typically reported, about 83% compared to what's usually found for immature habaneros.
That's fascinating. So we're already seeing how even the soil can influence the properties of these peppers. But the focus here is not really on the water content, it's on those other beneficial compounds, right?
Absolutely. We're talking about polyphenols, which are plant compounds that have been linked to all sorts of health benefits. They act as antioxidants, which help protect our bodies from damage caused by free radicals.
Okay, so we've got these habaneros packed with polyphenols. What is the challenge in harnessing their power?
The challenge is in preserving those compounds because they're delicate. Polyphenols are sensitive to things like light and oxygen and temperature fluctuations, which can all lead to them degrading and losing their beneficial properties.
So how do we protect these tiny but mighty molecules? That's where spray drying comes in, right? It's a technique for microencapsulation.
Exactly. Spray drying involves transforming a liquid solution into a fine powder. So in this case, they're essentially creating tiny capsules that contain those polyphenols, and it shields them from the elements.
I'm picturing like microscopic bubble tea, each bubble protecting a dose of habanero goodness. I imagine getting the recipe for those microcapsules just right isn't easy.
You're right, it is a bit of a balancing act, and that's where the researchers used a method called response surface methodology, or RSM, to try and figure out the sweet spot for drying these pepper extracts without damaging the polyphenols.
RSM, that sounds pretty high-tech. Can you break it down for us a little bit? What does that method actually involve?
So think of it as a way to figure out the best combination of ingredients and cooking conditions to get the perfect dish, but instead of ingredients, they're tweaking things like the inlet temperature of the dryer and the ratio of the pepper extract to a common food additive called maltodextrin.
Ah, so maltodextrin is like our secret ingredient here. What role does it play in this pepper powder recipe?
Maltodextrin acts as a carrier. It helps to form those protective microcapsules during spray drying, and it also contributes to the stability and texture of the powder.
Interesting. So the researchers are experimenting with these different parameters to see how it affects the quality of the final product. Did they find a winning combination?
They did. They found that a specific combination of inlet temperature and maltodextrin to extract ratio led to the best preservation of the antioxidants and polyphenols. We'll get into the specifics of that in just a moment.
Okay, you've got me hooked. Can't wait to hear what that winning recipe is. Let's take a quick break and come right back to unlock those results. Okay, we're back and ready to dive into those results. Last we left off, the researchers were experimenting with different spray drying conditions to see how they could best protect those polyphenols in habanero peppers.
And they found a winning combination. But it wasn't just about like any combination. It was about maximizing, certain polyphenols.
Okay, so break that down for us. We're not just talking about like total polyphenol content here, but about specific types of polyphenols, right?
Exactly. They were looking at a whole bunch, and each of them has its own potential benefits. For example, one that really stood out in their findings was rutin.
Rutin. I've heard that before. It's good for something, right?
Yeah, it's a powerhouse. Rutin is a type of flavonoid. And flavonoids, they're a subcategory of polyphenols that are known for their antioxidant and anti-inflammatory properties. Research suggests that rutin could be beneficial for, a lot of things, from your heart to maybe even protecting against certain types of cancer.
Wow, so this habanero powder could be like a secret weapon for better health. That's amazing.
It's really promising. And what's fascinating about rutin is that on its own, it's not that easily absorbed by the body. But when you encapsulate it, like they did in this study, it can actually increase its bioavailability.
So by protecting it in those microcapsules, they're making it more likely that our bodies can use it. That's really cool.
Yeah.
So rutin's a star player here, but what other polyphenols were they tracking?
Well, besides rutin, they also looked at the concentrations of other polyphenols, like protocatechoic acid, camaric acid, diosmitin, and naringenin. They even created models to try to predict how the drying conditions would impact the levels of each of these in the final product.
So they could like plug in different temperatures and maltodextrin ratios into these models and see what kind of pepper power they get out in the end. That's pretty impressive. Were the models accurate?
Well, the models were really accurate for some of them, like camaric acid. But for others, the actual results, they differed a bit from what they predicted, which just shows how complex these processes are, that even with really sophisticated models, there's always something new to learn.
Science is full of surprises, isn't it? It's fascinating how, even with the best plans, sometimes you have to just adjust based on what you see in the results. Speaking of surprises, did they measure the spiciness of this powder? I mean, we can't forget that we're talking about habaneros here.
Oh, they did. They measured the capsaicin and dihydrocapsaicin levels, which are the compounds responsible for that habanero burn.
Okay, spill the beans. How hot was this powder?
The extract that they started with had a Scoville heat unit rating of over 134,000, which is really spicy. Now, of course, the drying process can affect the heat levels, so they developed models to predict how the different parameters would impact the capsaicin content as well.
So they could, like, control the spice level, make it milder or hotter, depending on what they wanted to use it for?
Exactly. But I will say that their models for capsaicin weren't as accurate as for some of those polyphenols.
Interesting. Sounds like there's more to learn about how to preserve that heat. Okay, so we've talked about the chemical composition, the polyphenols, and the heat. But I'm curious, what did those microcapsules actually look like?
To visualize them, they used a scanning electron microscope, or SEM.
ISIUM. Refresh my memory. What is that?
Basically, it's a super powerful microscope that uses a beam of electrons to create images of surfaces at really, really high magnification. Think of it as being able to zoom in and see the texture and shape of those tiny capsules.
Wow. So what did those superpowered microscopes reveal?
The SIM images showed that most of the capsules, they were spherical, but the surfaces, they varied a bit depending on the drying conditions. Some were smooth, and others had different levels of roughness, even indentations.
So the drying process affects not only the chemicals, but also like the physical appearance of these microcapsules. I wonder if that influences things like how the powder dissolves or how it feels. Did they look into that at all?
That's a great question. That's definitely something that future research should explore. But to make sure that they had actually captured those polyphenols and the maltodextrin inside those capsules, they used a technique called Fourier transform infrared spectroscopy, FTIR.
FTIR. Remind me what that is.
It analyzes how infrared light interacts with molecules. Different molecules absorb infrared light at different wavelengths, creating a unique fingerprint for each substance. And by analyzing those fingerprints, scientists can identify what's in a sample.
So like a chemical snapshot of what's inside? Very cool.
Yeah.
Okay, so we know what's in them. We know what they look like. What about the color? I bet this powder isn't the bright green of a fresh habanero.
You're right. Color can be important for food and supplements, and it can also tell us something about what's in there. They measured the color of the powders using a spectrophotometer, which analyzes how much light is reflected at different wavelengths.
What kind of shades of habanero powder were we working with here? Was it vibrant orange, maybe a deep red?
Well, they found that the powders generally had like a light yellowish hue, and the luminosity, how bright it was, varied depending on how much maltodextrin they used. Higher ratios made a brighter powder.
Interesting. So the maltodextrin affects the texture and the brightness. What about any reddish tones? I mean, habaneros are red.
You think so, right. But they found that reddish tones were very minimal, which means those anthocyanins probably weren't there in high amounts.
Anthocyanins, those are the ones that give berries their color, right?
Exactly. And they're usually found in more mature fruits. This study used immature green habaneros, so that explains why the powder wasn't red.
That makes sense. So the color of the powder tells us about how ripe it was and what kind of compounds are there. But color isn't everything, right? What about moisture content? That's got to be really important for shelf life.
Absolutely. Moisture is key for stability and shelf life. Too much moisture and you get clumping, spoilage, and even those beneficial compounds can degrade.
So how dry were their powders?
No. Their results showed that. Powders that were dried at higher temperatures, like 140 degrees Celsius or above, had a much lower moisture content.
Makes sense. More heat, less water, but you don't want to overdo it.
Right. They found that around 4% moisture or less was ideal for stability.
Okay, so they got the color, the dryness, and the composition. What's next? Did they have any ideas for how to use this super powder?
They did. They see a lot of potential beyond just, sprinkling it on your food. They highlighted its potential as a functional food ingredient, adding it to snacks, beverages, or baked goods to increase the antioxidant content.
So my morning toast could be hiding habanero goodness. I like the sound of that. What else?
They also mentioned dietary supplements. Like, imagine a capsule packed with those habanero antioxidants.
That's a convenient way to get your dose. Any other interesting applications?
They even suggested that maybe future research could look at using it in cosmetics or even pharmaceuticals.
Wait, habanero pharmaceuticals. What would those be like?
Well, remember we talked about rutin and its potential anti-cancer properties?
Right, and the anti-inflammatory benefits. So we're talking about habanero-based pain relievers.
It's definitely early, but the possibilities are exciting. This research is really just the beginning. It opens up all these questions about how we can use plants for a healthier future.
That's what I love about science. It starts with something so familiar, like a habanero pepper, and then it leads to all these amazing possibilities. It's really cool to see how we can use scientific techniques to unlock the potential of these natural ingredients.
For sure. And this study is a great example. It makes you appreciate just how complex nature is and how much we still have left to learn.
This deep dive has been more than just a spicy adventure. We've learned about unlocking hidden superpowers in these peppers, preserving them, and how all this could change health and wellness.
And it all starts with curiosity.
I couldn't have said it better myself. But before we get too lost in these habanero dreams, we've got one last segment to go. So stick with us as we wrap up this deep dive into habanero pepper research. All right, welcome back. We've covered so much about habanero peppers, from the soil they're grown in to that whole process of spray drying, and how we might actually use this amazing powder.
Yeah, it's been quite the journey. We've seen how scientists are using these, cutting-edge techniques to unlock all this hidden potential and then preserve those compounds.
You said something earlier that really stuck with me. But this research, it's more than just about habaneros. Can you talk more about that?
Sure. I think this research gives us some key takeaways that go beyond just this one study, first of all. It reminds us that we have so much to learn from the natural world, especially plants. They're full of compounds with, so much potential. And we're just beginning to understand how we can use them.
It's like we're just opening up nature's medicine cabinet.
Exactly. And this research, it shows how powerful scientific innovation can be. By using, the right techniques and a good approach, we can get these beneficial compounds out, preserve them, and make them more usable.
It's so cool to see how science and nature can work together.
Yeah.
We're not just relying on the old ways anymore. We're using tech to open up new possibilities.
Right. And it's not just about finding these compounds. It's about figuring out how to use them.
So it's a call to action for scientists and for all of us to stay informed, be open-minded, and explore what nature gives us.
Absolutely. And I think that's what's so great about this research on habaneros. It really gets our imagination going, encourages us to think differently and see the potential in even the simplest things.
Reminds us that the world is full of amazing things to discover.
I think it's time to wrap up. But before we go, I want to leave you with something to think about. What other everyday foods might be out there, with hidden potential just waiting for science to unlock it?
That's such a good question. Makes you wonder what's next. Thank you for joining us on this exploration of habanero peppers. Until next time, keep exploring, keep questioning, and keep diving deep.